I'm going to walk you through the calculations for the potassium chloride mixture lab. In this lab, we are asked to go from the amount of oxygen produced to the mass of the potassium chlorate in the mixture. So since we are converting from one chemical to another, this is essentially a stoichiometry problem, which involves three steps. We'll find the moles of the oxygen, we will convert to moles of the potassium chlorate, and then we will find the mass of the potassium chlorate. From there, we should be able to figure out the percent potassium chlorate in the mixture. The items listed in purple are the data that you collect by observation. The mass of the mixture, the initial and final volumes on your eudiometer, the temperature of the water, and the air pressure in the room. The items in blue you will need to calculate by using some unit conversion or by looking at tables in the back of your book. We're going to assume that the oxygen collected is the same temperature as the water, but remember that the oxygen is collected over water and probably contains some water vapor as well. The table in the back of your book will indicate to you the vapor pressure at the temperature at which you're taking your measurements. Because the total vapor pressure is composed of both the oxygen and the water vapor, to find the pressure of the oxygen, you will need to subtract the water vapor pressure from the total air pressure. To find moles of oxygen, we will assume that it is behaving as an ideal gas, and we will use the ideal gas law, PV equals nRT. N, recall, is moles, and so we will need to solve the equation for moles, which will give us PV over RT. Recall that the gas constant R has very specific units, so we need our pressure in atmospheres, our volume in liters, and our temperature in Kelvin. You can convert the temperature in Celsius by adding 273.1. You can convert the pressure in millimeters of mercury by dividing by 760, and you can convert the milliliters to liters by dividing by 1,000. Plug these numbers into your rearranged equation using the value of 0.08206 liters atmospheres per Kelvin mole for the value of R. Remember that when you are plugging in your numbers into your calculator, that the calculator may not recognize that you are working with a fraction. So while all the numbers on the bottom are multiplied by each other, you will enter them in your calculator as divided by R, and divided by the temperature. You should end up with a very small number here, somewhere around 0.001 or 0.0009 moles. We've now completed the first step of the stoichiometry problem, finding moles of the oxygen gas. Now we need to convert to the moles of the potassium chlorate, the material about which we want to know something. So we need the balanced chemical equation. We're going to use the stoichiometric factor or molar ratio based on the coefficients of oxygen, which is 3, and potassium chlorate, which is 2. Take the very small amount of moles of the oxygen and multiply this by the coefficient of the potassium chlorate and divide by the coefficient of the oxygen. Your number should get even smaller at this point. We now have moles of potassium chlorate. Our third step in the stoichiometry problem is to find the mass of the potassium chlorate. So we have moles of potassium chlorate, and we will need the molar weight to find the mass. So we're going to multiply the moles by the molar weight in order to find that mass. You should end up with something between 0.07 and 0.1 grams of the potassium chlorate. Now remember, this is only part of the mixture because there's also potassium chloride, which doesn't react when it is heated. Since our ultimate goal is to find the percent potassium chlorate in the mixture, We will need to take the part of the mixture that is potassium chlorate, which is the mass of the potassium chlorate, what we just found, and divide it by the mass of the total mixture. And because it's a percent, we will multiply it by 100%. You are likely to find that your percentage is somewhere between 35 and 65%. You will need to repeat this calculation twice more for your 3 different trials. Now, because you're not apt to have exactly the same percentage each time, you're going to want to find the average of your 3 trials. Recall that for this, you need to add up the 3 percentages and divide by 3, the number of trials. It's also useful to find the standard deviation. This tells us how spread out your results are. Are they all clustered together, being very precise, or do they cover a wide range? For that, you will need to follow the calculation in the appendix for the standard deviation.